Right, question 27 says here the curve C has equation y equals 2x squared minus 11x plus 13. Part A then it says the point P has coordinates 2, minus 1 and lies on C. Find the equation of the tangent to C at P. Okay, when we're looking at the equation of the tangent, okay, we need two things. We need a point the tangent goes through. So you've got that point there, 2 minus 1. We also need the gradient of the tangent. Okay, now the gradient of it, right, we can get simply by working out the gradient of the curve, because the gradient of the tangent is going to be the same as the gradient of the curve where it touches. So to get the gradient of the curve, okay, you just do dy dx. Okay, so there's y dy dx. Bring the power down, so it'll be 4. You times that 2 by 2 is 4. X to the power 1. Okay, so and then you've got take away then 11x becomes 11. 13 then disappears when you differentiate that. So we say then at P, okay, which has coordinate 2 minus 1, dy dx will equal 4. Okay, you've just got to sub in the value of x. Okay, the value of x here is 2. So work that out. 4 times 2 is 8. Take away 11 is minus 3. Okay, so that is the gradient there of the tangent. Okay, at the point 2 minus 1. Okay, so the gradient of the curve at that point, but also the gradient of the tangent, because the tangent is going in the same direction as the curve at that particular point. So to get the equation then, the tangent. Okay, so if you're familiar with this equation, this setup, y minus y1 equals m, x minus x1, put the point in, so your point P is there, so your y value is minus 1, your gradient is minus 3, x value is 2. 2 minuses make a plus, multiply through by minus 3 then to get minus 3x, minus 3 times minus 2 is plus 6, so then this becomes y plus 3x equals 5. Take that one over the other side, it becomes y plus 3x equals 5. There's the equation of the tangent. Part B, it says the point Q lies on C. No, C is the curve, don't forget, and is such that the gradient of the normal to C at Q is minus 1/9. Find the x coordinate of Q. So if we think about here, what's going on here, here's your curve, right, and there's a point Q on it, right, and now they're saying the gradient of the normal is minus 1/9. When we mean the normal, okay, the normal is not this. Okay, that is your tangent, isn't it? That's your tangent at Q. The normal goes at right angles to the tangent. Okay, it's perpendicular to the tangent. So they're telling us the gradient here, so we call it M1, is equal to minus a 9th. Okay? So they're asking then the question, find the x coordinate of Q. So we actually want to work out what this coordinate is here. Okay, we don't actually know what it is. We want to work out what it is. Alright? Now, what we can do, if we know the gradient of the normal, right, which is minus 9th, we can actually work out the gradient of the tangent. Because it's perpendicular, of course, you can use this rule, where timesing the gradients together gives you minus 1. So, of course, to get then the second gradient, the one that's perpendicular to it, you just divide by m1, don't you? So if m2 equals minus 1 over minus 1/9. Now 2 minuses, when you divide it makes a plus, and you've got a 9th on the bottom, so take that 9 up, flip it, so 9 goes up, so you get 9. Okay, that is the gradient of the tangent. Okay, so now we've got this m2. Alright? Now, what we're asking, of course, is what this x value is, this coordinate at q. But what's great is we know dy dx. We know the gradient now of this tangent is 9. In other words, the gradient at q is 9. The gradient on the curve is 9 at q. So we know for the curve dy dx is equal to 9. If we go back to part A, we worked out dy dx to equal 4x minus 11. Okay? Well, of course, what we say in that q is that the gradient here is 9. It's the same as the tangent. So we can actually set this to equal 9. 4x minus 11 to equal 9. And then you've got a simple equation. 4x equals 20, which means x will equal 5. So that's your x coordinate at q.